What if I told you that you can run a powerful large language model entirely on your own machine, locally, privately, for free, with no API keys and no usage limits? That's what Ollama makes possible. In the next 10 minutes, you'll have Mistral 7B running locally, and I'll show you how to use it in a Python script just like you'd use the OpenAI API. Ollama is an open-source tool that makes it dead simple to download and run open-source language models locally. You install it like an app, pull a model like you'd pull a Docker image, and chat with it via a local REST API. No Python environment nightmares, no manual model downloads, no GPU configuration unless you want it. On a modern CPU, even an M1 Mac or a recent AMD processor, you can run 7 billion parameter models at perfectly usable speeds. The models you get aren't GPT-4. Be realistic about that. But Mistral 7B and Llama 3.18b are genuinely impressive for a $7 model. They can classify text, answer questions, generate code drafts, and handle structured prompts reliably. Go to ollama.com and download Ollama for your operating system. Mac, Windows, Linux, they all have one-click installers. On Linux, it's even simpler. One curl command from their documentation, and Ollama is installed as a system service that starts automatically. Once installed, open your terminal. Run Ollama, run Mistral. This downloads the Mistral 7B model, about 4 gigabytes, and drops you into an interactive chat session. Type whatever you want. You're talking to a real language model running entirely on your CPU. No internet connection after the initial download. Here's the part that makes Ollama genuinely useful for builders. While Ollama is running, it exposes a local REST API at localhost port 11.434. You can call it from any programming language. And it's OpenAI compatible, meaning existing OpenAI SDK code often works with just a URL change. In Python, using the official Ollama library, pip install Ollama. 3 lines of code to call the model programmatically. Import Ollama. Call Ollama chat. With your model name and messages array, print the response. It returns in the same structure as the OpenAI response object. This is the key insight. If you've already written code using the OpenAI SDK, swap the base URL to localhost and your model name to Mistral. Same code, 0 API costs. Where does a local LLM actually make sense? First, data you can't send to the cloud. Medical data, legal documents, proprietary business information. Anything you're legally or contractually not allowed to send to a third-party API. Local means private. Second, high-volume, low-stakes classification. If you're running sentiment analysis on 100,000 customer reviews and you need it done overnight, run it locally, free, as fast as your hardware allows. Third, development and testing. Don't burn API credits during development. Use Ollama locally. Switch to Claude or GPT-4 for production. Fourth, offline environments, edge computing, air-gapped systems, or just wanting a reliable setup that doesn't depend on internet connectivity. On a modern CPU without a GPU, you'll get roughly 10 to 20 tokens per second with Mistral 7B. That's slower than cloud APIs, but fine for batch processing. If you have an NVIDIA GPU, Ollama automatically uses it. Set the Ollama num GPU environment variable to tell Ollama how many GPU layers to offload. Full GPU offloading on an RTX 3080 gives you 60 to 80 tokens per second, comparable to cloud API speeds. For memory, Mistral 7B requires about 5 to 6 gigabytes of RAM or VRAM. Llama 3.18b is similar. If you have 16 gigabytes of system RAM, you can run these models alongside your normal workload without issue. Install Ollama in one command. Pull Mistral in one command. Call it from Python in 3 lines. free, private, unlimited. This is your development environment and your fallback for cost-sensitive production workloads. The full Python integration code is in the description. It includes a comparison script that sends the same prompt to Ollama locally and to Claude via the API, so you can benchmark the quality difference for your specific tasks. See you in the next one.